Welcome to another TSE single slider. This slide is all about HTTP redirects. You know when you type in a URL and then it changes? That's a redirect in action. Let's take a look in our first example. Let's say you type stripe.com/sessions/2022 in your web browser and hit return. This tells your web browser, the client, to send a request to the stripe.com server to fetch or get the URL you typed. In this example, the server receives the response and responds not with the page you requested, but with a redirect response. An HTTP redirect response has a status code in the 300 range. In this case, the code used is 307, a temporary redirect, which we'll talk more about later. The response contains a location header which tells the client where to go instead of the URL provided. In this example, the server is telling the browser to go to sessions.stripe.com to find what it's looking for. The web browser follows the instructions in the redirect response and makes a new request to the server hosting sessions.stripe.com. This time the request tells the server they want the front page, also called the root, which is indicated by a single / after the get HTTP verb in the request. This time the server responds with HTTP status code 200, which indicates success, and the response contains the HTML of the page. After all this happens, the URL in the web browser is changed to reflect the new page being displayed. Note that everything shown here happened behind the scenes. The only thing the user of the web browser did is type in stripe.com/sessions/2022 and hit return. From there, the web browser made the initial request, got a redirect response, made a second request as a result, and finally received the web page in question. Okay, let's look at a second example with some key differences. This time we're going to type in stripe.com/about and see what happens. The process begins the same way, with the web browser making a request to the server for the about page. The server responds with a redirect, but this time it's a 301, which indicates the page has moved permanently. Also note the location header. This time the location provided is a lone /. This means the server is saying the about page has moved permanently to the front page of the site. In other words, the server is saying the front page is the about page. Now the web browser makes a new request for the front page to the same server. The server responds with the front page HTML, the browser updates the URL, displays the page in question, and all is well. Have a look at the first example again. In that example, there were two servers, with one server redirecting to another. In the second example, only a single server is involved, but the number of requests and responses are the same. Most redirects result in the client making a brand new request, which can make redirects costly, especially if they're chained together. In fact, you may have seen an error in your web browser at some point that said something like too many redirects, which means one redirect led to another redirect, and that redirect led to another, and so on until the web browser gave up. This is what's happening behind the scenes when you see that error, but multiplied many times. Also note that both of these examples are real. You can try them out in your web browser right now, or use a command line tool like curl to see the actual HTTP requests and responses. If you try curl, make sure you add the -v flag for verbose output. So what are some common use cases for HTTP redirects? Some people prefer their website's URL to start with www, while others prefer to strip www off if it's present. A web server can be configured to redirect to or from the www version of a URL according to the preference of the site owner. Another very common use case is to redirect from an insecure connection to a secure one. A server can be configured to force all URLs that start with HTTP to instead start with HTTPS, to ensure nothing is sent over the wire that's not encrypted. As you might imagine, Stripe has this type of redirect in place pretty much everywhere. Redirects are also useful to create easy-to-remember or easy-to-type URLs. You can create a redirect from a simple short URL to a more complex one, such as creating a redirect from something like example.com/buy to a payment links URL. Redirects always have a status code in the 300 range. The ones most commonly used are shown here. Note that some are used for permanent redirects and others are used for temporary redirects. Some of the redirect statuses have specific technical differences as well. Take 301 moved permanently and 308 permanent redirect, for example. Both are used to permanently redirect, but 301 allows the HTTP method to change, where 308 does not. This array of redirect options allows for a lot of flexibility and fine-tuning. For instance, in the first example above, a 307 temporary redirect code was used, which tells the client that future requests should be made to the original URL, not the one redirected to. However, in the second example, the 301 moved permanently code indicates the original URL should no longer be used, and future requests should use the new location provided instead. Some clients take note of things like this to make future requests more efficient by avoiding an unnecessary redirect. One other note about these redirect status codes. Most of them redirect to a server, either a new location on the same server or a different server entirely. But 304 not modified is different. 304 tells the client the content being requested has not been modified since the last time it was retrieved, so the server is redirecting the client to fetch the content from its own cache instead of getting the content from a server. This is possible when the request to the server includes special headers that tell the server what the client already has cached from a previous request. Okay, now let's talk about something Stripe specific. Stripe webhooks treat redirects as failures. When Stripe makes a request to a webhook endpoint's URL to deliver an event, we require the server at that URL to return a successful HTTP status code, which is something in the 200 range. Unlike a web browser, Stripe's servers consider a redirect response to be a failure, and we do not follow the redirect. Redirects are one of the most common causes of webhook delivery failures when people are building new integrations. The reason Stripe's webhook system does not follow redirects is that it would put too much strain on the systems involved. As we've seen above, most redirects, if followed, result in a brand new HTTP request. Stripe sends a huge number of webhook requests every day, and it's not uncommon for many thousands to be sent to a single user's server in a short period of time. If we followed redirects, that would instantly double the number of requests we need to make to servers that respond with redirects, or even triple them if one redirect led to another, and so on. That means it would also double or triple the number of requests those servers need to respond to, resulting in undue strain on both sides. Thus, in order to keep both our users' critical systems and our own performant and stable for everyone, Stripe treats redirect responses from webhook endpoints as failures. A direct URL is required to avoid the inherent overhead redirects introduce. So now you know a lot about HTTP redirects, how they're used, and why the URL in your browser sometimes changes to something you didn't type. You also know the first place to look if you're building a new webhooks integration and you're getting an error that mentions redirects.